Moving observer, photon light source, light theory that has not even flying. Wave mass, wave movement difficulty. August 9, 2020. Please translate Japanese papers into your native language. Last time, the wave once the speed is expressed as the speed of light proper, but I feel better prospects in others. This time, the light of the observation reference system, the speed of light in a vacuum of the same inertial system, and the observer is constant, in the mass of do the definition. Einstein introduces proper time to what he sees from the flying light. However, in that case, I accept the contradiction, paradox of the clock, of not observing the time delay with each other. In order to make a pseudo-inertial system which is indistinguishable from a non-inertial system, we have to purposely introduce acceleration. The root cause that allows such contradiction is the problem of classical mechanics in which the observer does not treat the object at the time of coordinates, that is, the observer does not treat it as an object like a virtual object. A complete explanation of the concept of coordinate time arises from the relationship between eigentime and clock synchronization. Since many of the assumptions inherent in classical mechanics and classical spacetime have to be removed, synchronization must be carefully defined in the framework of general relativity, with the notion of concurrency. Of course, it does not completely deny the effectiveness of relativistic mechanics, but after all it is impossible to place an observer in the flying light, and particle nature in physics is an interaction. This is true of the absence of an observer. Of the Mercury perihelion movement described, the era of general relativity is no questions asked in the Mercury of mass point to handle delta function problem Uketamojiru A. The observer's physical interpretation did not pose much of a problem in Newtonian dynamics of absolute time, but in the time-varying optical reference frame, the problem becomes apparent. Especially quantum theory of measurement problem essence of the dealt with observer virtually the presence of implicit particles assumptions, Einstein's theory of relativity in. Here's a quote from his 67-year-old autobiographical note 9 years before his death. First, let me give one remark on this theory, the special relativity theory, that is characterized as above. This theory has two kinds of physical ones, apart from four-dimensional space, namely, 1. The fact that it introduces a measuring rod and a clock, and 2. Everything else, such as electromagnetic fields and matter points, gives a sense of strangeness, which in a sense is inconsistent. The measuring rod and clock would have to be represented as a solution of the basic equation, an object consisting of the coordination of moving atoms, not as if it were theoretically trivial, because theoretical assumptions can lead from it to a sufficiently complete equation of a physical event without being sufficiently arbitrary, their not being so strong as to underpin the theory of measuring rods and watches. If you don't generally want to give up on the physical interpretation of coordinates, something that is possible by itself, you should allow for such a contradiction. Of course, in later work of theory, it needs to be removed. 1946. The following is the correspondence between the Newtonian mechanical energy and the energy expression in the optical reference frame. An observer who moves in the observable universe is an entity with mass. The story is, if you have an observer who doesn't have mass, bring me one. The observation target may be an object or a photon. For example, if a current observer observes a distant galaxy long ago, W equals square root c squared plus v squared. 1. The speed of light, W, of proper can add infinitely the retreat speed, v, of a distant galaxy to the speed of light, c, of the observer. This means that the speed of light, W, in ancient times was faster than the speed of light, c, of the observer. Similarly, the speed of light of a proper photon seen by a moving observer changes as well. Moving observer, photon light source, observation target. We can infinitely delay the observer's time, and accelerate infinitely. The momentum of light in that case is P equals hf c equals mg c equals miw, 2. Therefore, the new definition of the mass in the optical reference frame is difficult to move energy. This is also consistent with the new kilogram definition. The kilogram, symbol kilogram, is the SI unit of mass. It is defined by taking the fixed numerical value of the Planck constant h to be 6.626070151034 when expressed in the unit JS, which is equal to kilogram m2s-1, where the meter and the second are defined in terms of C and CS. And of course, the atom that defines the second has mass. The second, symbol S, is the SI unit of time. It is defined by taking the fixed numerical value of the cesium frequency Cs, the unperturbed ground state hyperfine transition frequency of the cesium-133 atom, to be 91926317770 when expressed in the unit Hz, which is equal to S1. Popular